So you'd like to make a full R2D2 in a weekend, maybe not a full-size one, but you can certainly have a go at making a small-scale 3D printed, complete with all the electronics to make it move. So let's build an R2D2 in a weekend. So what we're going to need is one roll of filament, approximately, 2 ESPs, 3 continuous rotation servos, 6 tactile micro switches. I'll demonstrate those in a little while. You only really need 4 for now, but 2 are later for the dome and sound control. Some prototype board or breadboard. I'll be starting on breadboard, then moving to prototype board. Some header pins, a sorted wire, a capacitor or 2, and some power supply. So I'm using a 4AA battery pack in my actual DROID, and I'm just using a power bank in the controller, but you can use AA packs for both if you want. And then optionally some LEDs, a buzzer, piezo buzzer, and a DF player. That's an MP3 player, so we can make it have the sound effects, but they'll be coming in a later video. Okay, so this is our method. Stage 1, download all the files, prepare and print them. While it's printing, we can move straight to stage 2, test and calibrate the servos, start building the circuit boards up, then copy the code across, make sure the connection's all working, take a bit of a break hopefully at that point, wait for your files to finish printing, and then we can assemble the whole thing together, and you've got yourself a working DROID from start to finish, and you've done everything yourself. Okay, so tools you're going to need: soldering iron, wire strippers, screwdriver. Might be a few more along the way, but we'll figure that out. So the first step is go and join the Michael Badley Patreon if you've not done so already. You'll get a download link, click on that link, the PDF document will tell you where everything is stored. So find the BBR2 folder, download the files, and then we can open your favourite slicer and then send to your printer. Okay, so I'm in Bamboo Slicer. Now the settings aren't as strict as this is for a full-size Astromech. But I've just gone with 3 walls, 15% infill. This is probably stronger than it needs to be, but it'll make it nice and sturdy. So I've already pressed the slice button. In fact, before I go any further, support. No support. You do not need support for these. I know some of you might feel a bit nervous about it because this is your first time on these sort of things. There's this massive section just here, but it will absolutely bridge this. Have faith in Michael for this working correctly. So set that printing up, because that's going to be 4 hours. So this gives us 4 hours to start getting on with some of the other things. In fact, maybe printing the legs first could be a good idea, because then you can attach the servos. Same for the dome. The dome also does not require support. Just send to the printer. I like to do 1 print file at a time. Some people like to fill the bed with as many things as possible in one go. I'm never brave enough for that. So as we can see, that's going to take 3 hours. So now we're up to just over 7 hours for the body and the dome. The legs and cogs will probably take another 2 hours. So again, you could have this done by tea time if you start off in the morning. Okay, so this is now stage 2. So this is going to be the heart of our drive system, and this really is it. We've got an ESP at the heart, the microcontroller. We've then got 2 micro servos. There will be a third, but we're not going to worry about the dome just yet. And then a battery pack. I'm just using 4AA batteries. I'm not using any voltage regulation because I'm playing life on the edge. As long as you keep it to the if you've got like 4 rechargeables, it'll only be 4.8 volts, which we can hook up to the 5 volt pin, so it'll be fine. And a microcontroller of this size will happily power 2 of our little micro servos. I would recommend not hooking up to a full-size servo. Please see my other videos on servo controls. Okay, so what we're going to do is we're going to hook that directly up. We need to calibrate these servos. Now, when I built my first one, I'd never used continuous rotation servos before, so I built the whole DROID up, the one you can see just here, and it was twitching and moving all over the place, and I thought it was my fault. Have I done something with electronics or the code? It wasn't. I just not calibrated the servos. So that's going to be our first step. So to do that, we're going to write a little bit of code. So if you're new to this, please don't worry. I'm going to jump into Arduino now. This is the Arduino IDE. This is free to download, so you can just download it, install it. So I'm including the servo.h library. This gives us all the code support for handling servos, so we don't have to worry about the real low-level coding to make them work. You may have to go onto the managed libraries. So in the managed libraries, you can just type in servo. There we go, we can see servo Arduino installed, and that's it. I mean, I could press update, but I'm not going to that while I'm doing the video. So that's the library. Like I say, it gives all the code for handling servo control. Servo, my servo, that's just this is just for testing purposes. Void setup, so this function will run once only. When you turn the chip on, when you give it power, that will run straight away. So I'm saying serial.begin. This is, you don't need this, but this will send data through the USB cable back to the computer to give us some information. This helps for just testing things. Serial.println, if you've ever done Hello World, this is Hello World in an Arduino or ESP. And I'm just saying servo tester on D2. Oh, I've changed that, haven't I, to D3 on the wiring diagram. I like to output what this chip is doing, because if you're anything like me, you might have 50, 60, 70 of these lying around in different projects, and then they get pulled out and you forget what it's doing. So I like to plug it in and just check to see what code is actually on here before I try plugging it to the circuit board. So this is not needed. I just like it's my standard. So I'm now attaching the servo, and I want to attach it to D3. Reasons will come clear later on. D3 is my digital 3 pin, which I think we saw on this slide. There we go, it's the D3 pin on this ESP. And I'm saying write 90. So if this was a normal servo, not a continuous rotation, it would immediately go to 90 degrees, as fast as it can possibly manage. With continuous rotation servos, 90 degrees is stationary. Anything negative will rotate backwards, anything positive will rotate forwards. So and obviously 0 will be as fast as it can go, whereas 89 will be moving very, very slowly. So we can play about with numbers, but we're not going to worry about that right now, just in case you like that information. So this is basically our initialization function. Then inside the loop, this will repeat as fast as this chip can manage. So again, I'm serial printlning in loop, and I'm delaying 1 second because this is doing nothing for us at the moment. This is to test that this chip is working. It's really important to make sure your stuff is operational before you start worrying about integrating into projects. Okay, so again, if you're new to Arduino, I'm going to just go on to Tools, Port. We can see I've got something on COM1. This is not plugged in yet. I'm ignoring COM1. That's your communication port. Everything you plug into your computer has a COM port. So I've got a USB cable. I'm just going to plug it in. We should hear it go bing bong. Okay, so if you heard that, that's fine. It means that it is talking to the PC. If you don't hear a bing bong, please check your cable, just in case you've got a charging cable rather than a data cable. So now I click on Tools, Port, COM4, and it's automatically ticked it. It doesn't always do that. The very first time I did Arduino programming, I couldn't get it working. A friend said, have you ticked your COM port? No, I hadn't. So either way, it's now working. If I go on to Tools and I go Serial Monitor, this is now telling me it's in a loop, so I know it's working. If I just press the reset button on it, there we go, it's put my little title that you just saw. This is now ready for testing, although this is the old code. So we can now prove this is working. The tick button just verifies you've written your code correctly and all your libraries, but it doesn't do anything else. If I press the upload button, it will do all of the verify and then upload it, and this can be a little bit slow. Also notice while it's compiling, I set the speed to 9600, which is what this is set to. If these have got different numbers, it won't communicate accurately. Sometimes you'll get glitchy data coming through, sometimes nothing at all, and again you might think it's broken. Okay, we can see it's uploading, it's trying to connect, it's copying it across. We should see this reset. I'll just press reset on the ESP chip. There we go, we've now know it's got the next bit of code on there. Now we could do all this with a simple transmitter and receiver, plug your servos in, calibrate your transmitter to be a mixed, and then off you go. Same drive system as what you would use for a full-size one. But where's the fun in that? And by getting to the hang of this ESP Arduino stuff, it'll empower you to do a lot more within your projects. Okay, so over to the workbench. Okay, so the first thing is I'm just going to plug the wires in. So I've got my servo. I'm sure it's fairly obvious, but if it's not, the orange cable is for the data signal, red is for the power, and brown is for the ground. So I've got the breadboard, got the ESP on the breadboard. I'm just going to plug the orange straight into D3. I'm going to plug the red straight into 5 volts. And then the brown into ground. So that's our servo connected up and ready for use. I've got a little power bank just to my side. I'm just going to plug into the power bank for the moment. This will be fairly safe doing it from your laptop as well, or a computer. Okay, I was expecting to see a bit more twitching than that. If it's not twitching, I'm just going to prove a point. There we go, so that's if it's not calibrated. Underneath is a little screw, and we can rotate this until it's nice and silent. So you can see I'm just going from side to side, just to prove a point. There we go. So I've found sort of the dead spot. So that should be okay to go. And now I would do my other servos. Okay, as I've just put it down and opened the packet for my next servo, this one started up again. So I have to just sort of have a little play, see if I can find the sweet spot a little bit better. I think if I was redesigning the foot shell, I might kind of keep that screw available, like an access slot. Okay, this one's brand new, fresh out of the packet. So same again, little screwdriver. There we go, found the spot. So I might just leave these turned on for a little while just to make sure that they are calibrated. Okay, so our next step is to now make our actual receiver and drive control system. So you can probably see from this amazingly technical diagram that I've created in Paint, this is our drive system. So it's the one ESP, the one 4AA batteries, which is what I tend to use, and the two servos. Again, we'll come back to the dome controller later on. But let's just go through these steps if you are new to this sort of thing. So I've gone to Photoshop, I've got my breadboard. Again, if you're new to breadboards, I'll explain how these work. All these pins here are all connected together. This is one long series of connections, which of course you don't have to connect positive. There's no power in there yet until we connect it up, and the same for negative. These pins are also all connected, but this row of pins is not connected to this row of pins. If you want to practice with this, please go and check out my other videos on introduction to Arduino programming. I use Tinkercad for demonstrating these, and you can play about with them without risk of damaging anything. So I've got the breadboard. My next step is I plug the ESP in carefully, not to bend the pins. These can take a bit of a push, especially new ones. And I've made sure that I've got a row of pins to either side available. Some people ask, why don't I use ESP32s? Because they don't fit on breadboards very well. You need the more expensive and bigger breadboards, or putting breadboards next to each other. That's why I use these, because it's just simple and convenient. So next step, I'm connecting the 5 volts straight to this rail. So now this Arduino, this ESP, is going to provide power to this entire column of positive pins. And likewise, I've connected the ground to the negative, to the ground rail. So now I've got positive and negative running all the way up and down this breadboard. This makes it easy for when we're doing multiple things, multiple sensors and actuators. So then I've got the battery pack. So now the battery pack, again, the positive is connecting directly to the positive rail, negative to the ground rail. This means I am now powering up the ESP. So it's sending power directly to this. Now the ESP, I believe, can handle sort of between 4 to 7 volts. I think I have to check up the specs. So again, if you put 4 alkaline batteries in, which are obviously coming at 6 volts, it's still fine. Okay, so our next step, we've got our servo 1, servo 2. So I'm just going to connect our red cable straight to that pin. Our next one, red, to that pin. Doesn't matter again which one, it's just connecting that rail. I'm going to connect the ground. So again, the ground wire is going to come to the ground wire to the ground. Advantage of this method, by the way, is the batteries are all sending the power directly to the servos. So it's sharing the battery straight to servos, batteries to the ESP, rather than it being the USB power, sending the USB through the board, through the 5 volts, and then into the servo. So this is a better method. So I'm not using USB power bank on the receiver end. So now the final connections, I mean, it's probably fairly obvious to most of you by now, but if I just now connect the orange wire, this is going to go to D4, this is going to go to D3. Again, it doesn't look neat, but that's our wiring. Okay, so So we are over on the workbench, so let's make a start. I've grabbed some jumper wires, but you could just get some normal wire and strip them down to the right size. We'll probably do that later when we do our prototype board version. Okay, so I'm just going to plug the red into the 5 volts into our rail, ground into our ground rail. It might seem silly, but always double check these things, make sure that you've not accidentally cross-wired or short-circuited anything. Also, we'll go for real. We'll take these extension cables out, maybe put some pins in those instead, just while working the breadboard. So I'm going to put this one into D4, put that one to the positive, and that one into the negative. So just like I did on my awesome technical drawing. You don't need to colour match, but obviously it can help make a few mistakes. Okay, one of the next steps I like to, before I start messing about with a more complex code, is I like to do a quick test to make sure it is working as we expect with just the motors. So I'm just going to do a quick save as. I'm just going to call this BBR2RX_01, so against my naming convention. I'm going to come down to the loop. In fact, I need another servo now, don't I? So I'm going to have, let's rename this. So this we can call left motor. And of course, right motor, which means I'm now going to have to call this LM and LM. Again, I can copy and paste and change to DM. Nope, that's because me usually doing the dome motor next. Okay, so I've now got left motor, right motor, change that to D4. I might need to switch these around depending on what I'm up to. Okay, so I'm now going to come down into the main code, and this time I'm just going to grab that line. I'm just going to say, so we're in the loop. I'll just comment that line out for the moment. So we're going to write 90, in fact, yeah, because we're already at 90 up there, aren't we? In fact, no, I'll leave that in. So I'm going to write 90. I write 90, don't need that, do I? I'm going to put that into 0. So basically we're going to turn both motors to go the other way. Now it's possible they're going to go in alternative directions. That's why I think it's important to test these things first. So right motor 0, left motor 0. Let's put a delay in. So it's going to spin for a second, it's going to stop. And then I can just copy these. Then I can say let's put these to 90 to make them stop. So we're going to go one direction for a second, we're going to stop for a second, and then we're going to go the other direction for a second. I mean, maybe the second's too fast, but we'll play and we'll see what happens. This is just going to make sure everything's going the way I feel it should. So I'm just going to drag my chip over. Should have copied this across before wiring it up, but that's fine because now when I plug it in, it's going to start messing about with them. So I'm plugging in. Okay, one of these is already moving when it shouldn't, so it needs to be calibrated again. Maybe I've made a mistake with it. So just grab my screwdriver. Okay, so that should have stopped that now. Let's copy this code across. Just going to check the ports right. Yep, the port's fine. Okay, they do seem to be working in the way they should. Forwards, backwards, stop, forwards, backwards, stop. Okay. Now it did throw a little glitch when I was copying the code across, so I just pulled the red wire out from the positive rail just in case the current draw from the servos was stopping the USB port from working. Sometimes it can do a bit of glitchy things. Okay, so I've just reconnected the red wire. So I've got my battery pack. Now my battery pack is a female connector. so I'm just going to have to use another couple of jumper wires to go between. This is not ideal, and we should really do it properly, but again, this is just proving the prototype code works. Okay, so now this is always the fun bit. Am I about to blow something up? Are we about to let the smoke out? So I'm just going to plug these straight in. Now this is a box with a switch on it, which I do prefer. So I'm just going to connect these up, making sure I don't mess them up. Again, doesn't matter which socket you put them into. What I'm doing is I'm also putting my finger on there, so if it starts getting warm, I know I've short-circuited something, and you can generally disconnect in time. There we go. I don't know if you noticed the sound difference, but they definitely seem to be running faster now. They're coming off AA batteries rather than USB port. Okay, so that's now the easy bit sort of done, which is making the receiver electronics part. The next stage is to make ourselves a little transmitter. Blue Peter fashion, I've already made one. In fact, I've made several of these. I've even controlled my big DROID from one of these, but I wouldn't recommend it in a convention centre. So our basic transmitter, just like with receiver, it's an ESP, but it's now some little switches, so you can control forwards and backwards of each servo, and some wires. So let's just go through the process of how I've put this together. So for this one, I've started off with a small breadboard. These quite often come free, well, these often quite come included with Arduino starter kits. It would actually be better on a prototype board, but these take a bit more time for setting up. And again, I like to test things before I start soldering and hardwiring stuff. So I actually got two of these and put them together for reasons that I'll explain on this next bit. So I've got two breadboards, just slot them together. You can see they've got these like jigsaw style edges. I've had the ESP. There's no reason putting it at the top. This does make getting to the USB cable a bit more tricky. It's just how I was feeling at the time when I was experimenting with this. So I've got the ESP and it's now spreading across. This is to make sure that this join here means these pins are not connected to these pins. Okay, so the next step is to add our switches. It doesn't matter whereabouts you put them really. I've just made sure I've got a gap on this side. It is important that they're rotated the correct direction. So if you notice, they've got the pins on this side because this is all connected across. And that's how they connect on the inside of the switch anyway. When you press the switch, it forces these two to connect to each other. So that's the direction they sort of need to be in. Okay. So our next step is we're adding the ground wire. So if you notice what I've done is I've connected the ground to this one row here, because unlike the other breadboard, we don't have a continuous rail for positive and negative. So I've just connected the ground rail to this one. So this now becomes my ground set of pins. And then I've spread this wire, come up to this one side, this to this side, and obviously, well, you can see the others. This is just so it's easier here than it may be on the webcam itself. So once I've got all the ground connected, we now make the circuit by connecting the other pins. So if I just bring the last bits on, so I've connected D4 to this pin, D3 to this pin. So when we press the switch, it's basically making a short circuit between our digital pins and our ground. Now that normally would be bad. We'd normally have to put a resistor between the switch and the pins. However, ESPs and Arduinos have something called a pull-up resistor on the inside of the chip. As long as we activate it in the code, everything is fine. Again, if you want to know more about that, see my other tutorials on Arduinos. And again, same for this side, D8, D7 hooked up to these pins. So this is our simplest connector. This is our simplest transmitter that we can make. I will also probably add a capacitor to this. The capacitor helps stabilize the circuit. It makes the Wi-Fi more stable. Sometimes without the capacitor, the chips actually don't start up. They just stick in a boot loop, and that can get your chip very hot, burns it out and kills it. But we'll worry about that later. Okay, so over to the workbench and let's make ourselves a new transmitter. Sometimes you have to squeeze these pins in a little bit to make them fit. Now I'm out of brown and red wires, so I'm just going to have to make this up now. I bend it slightly to make sure that when I pull the wires off, it doesn't pull the core through as well. Okay, and there we go. We have one board that pretty much matches. Actually, there's no capacitor, there's no LEDs or anything just yet, but we'll look into that shortly. Okay, so our next step is to make sure this board is working. Have we got the wiring right? Is there any short circuits or any problems with it? To do that, we're just going to code and make sure the switches are flicking on and off. Okay, so I'm back into Arduino IDE. I've created a new file. Before I even start, I'm just going to do save as. I'm just going to call this BB R2TX for transmitter _01 in case I make new versions later on. Always important, save your files as regular as possible. You don't want to lose that work. So let's just have a quick look what we're doing. So to make this a bit easy for us, I'm going to do some defines. This is just setting up the names of things. So if I go hash define, not define, define, and obviously I've got 4 switches. So I've got left forwards, so I'm just going to put LF left forwards, and this is going to be on our, again looking at our chips, this is hooked up to D7. So again D7. I'm going to define our next one, define L. Now I can never decide to do LR for left reverse, but then the R can be confused for right, or just LB for left backwards. Entirely your choice. I'm just going to stick with LB for now because I'm lazy. Copy and paste, and I'm just going to put for right forwards, right backwards. So have a quick look at those chips. What were they? What did I say they were? So it's D3 for forwards, D3 for forwards, and D4. The good thing about this is if you then want to change the pin configuration around, you just change these numbers here, and the rest of the code will still remain the same. So no messing about with it. So inside our setup, this is the important bit, the part where so we don't have a resistor. So I'm going to say pin mode, and this is going to be our LF, pin mode LF, input underscore pull up. Now again, you don't need to worry about memorizing all of this. You can just, I'll put this code in a link below. You can just download it and copy it across if this is not your thing, but it's still really useful if you want to build a big R2 and you want to start using things like the Padawan system. If you're familiar with how this code works, you'll be able to edit those things yourself. Okay, so I'm just going to copy and paste this. Again, being lazy. So LF, LB, right forward, right backwards. Okay, so there's our input pull-up. We're using the built-in resistor and we're making these all switches. So what I'm going to do is also set up the serial output so we can see on screen exactly which switch has been pressed. Again, I'm lazy. I'm going to grab this bit of code so I don't have to retype it. Again, serial.begin. I didn't need to tab that, by the way. And this is just going to be our switch test. Could you know, put TX switch test. Okay, so I'm in the main loop. I'm now going to check. So if we use a selection statement, an if statement. So if I press this button, if I push it down, then it's going to give us an output on screen. So I'm just going to say if digital read, and I want to read the LF switch. So if is equal to low. So if I've pushed this switch down, it's going to say, yep, we've connected. We're now going to do an output. Now, if you're used to Python, you've got to use colons and all sorts of indentation. I'm just going to do this on one line. It's bad programming practice, but it's easy for me to follow what I'm doing on screen. So if it reads low, I'm just going to drag this line here, copy, so serial.print line, and I'm just going to put LF, semicolon to finish the line. Okay, so now if I press the low button, just output that, and I'm going to just copy and paste this line again to test all the switches. So that's going to, in fact, I'll just do this all in one go. Okay, so now I'm just going to quickly change that to, that was the wrong one, wasn't it? So LB, right forward, right backwards, again change this to LB, RF, RB. So now it's going to print those out, and just to make it a bit easy to see on screen, I'm just going to slow it down a little bit. So delay 500, so let's give us half a second before it loops back and checks again. Okay, let's just save that. So I'm just going to plug this in. This is where, unfortunately, putting it further a breadboard is a little bit trickier to get to. Not only is it tricky to get to, I've had to make a longer wire to bridge over the USB cable. Okay, it's a different ESP, so I'm going to just check that it's on the right COM port. So COM port, yep, it's still just there. COM1 originally is probably my hub reader, so it's still there, that's fine. So I'm going to pop open the serial monitor. That's just running the code from an earlier version. So I'm just going to upload this. I try not to mess with the serial monitor while it's compiling and uploading. It can sometimes upset things. Okay, so now it's compiled, run across. It's flickering LB, so it thinks left backwards is being pulled all the time. Now if I press the other switches, so there we go, right forwards, so that's fine. Right backwards, that's fine. Left forwards, that's fine, but it's obviously got a problem with LB. So I've have a close look at the wiring. The wiring looks absolutely fine. So what we're going to do is we're going to have a quick look at the wiring diagram, the pin out of this chip. So if I just pop up a pin out, so you can see all these pins, it says outputs, yeah, they're okay, but D8 is saying it's okay for an output, but it's saying input is already pulled to ground. So really, I should not be using D8 as an input. Now, if I have a close look at my older board, I am not using D8 on this board, so obviously I made the same mistake last time, but didn't document it. This is the reason why we do breadboards first. We make sure everything is happy before we start soldering and making things elsewhere. Okay, so what we're going to do is we're going to quickly rewire this. We're going to push it over, so instead of it being D8 and D7, we're going to make it D6 and D7. So I've just quickly swapped the wires over. I'm going to pop up here and just put that to D6, move that one to D7. Let's copy the code across and see what happens. Okay, so the code's copied across, it's compiled, just waiting to press buttons. So if I now try it, so left forward, there we go, left forward, left backwards, right forwards, right backwards, and of course if I press them both at the same time, we should see them both appearing at the same time. So what's that phrase about failing fast? You know, we've tested it on a breadboard, didn't work, we've played with wiring. Yes, you'd always read documentation, but if in doubt, try it. What's the worst that's going to happen? Okay, so our next step is to actually now make these devices actually talk to each other. So we're going to use something called ESP NOW to allow to use the Wi-Fi connections in the ESP to sort of communicate our data between the switches and the servos. So rather than you watching me type lots of code, I've already written it, tested it, make sure it works. I'm just going to talk you through how the code's running. If you're not interested in that, you just want to use it, again, there's a download link below, and you can just jump to the end of this chapter. That will show you how to copy the code across and the bit that you will need to do. Okay, so if we just load up my receiver, so I've used the same version as before. I've done save as version 2, and I've started to include the other bits. I have had to make a change. I called it LM and RM for left motor, right motor, but that clashed with some of the other code I'd already previously written. So I've now called it LS for left servo and right servo. So there we go, I've got these two servos just as before, but now I'm including the Wi-Fi stuff. So I'm including Arduino.h, that's just a library full of Arduino things we need. The ESP8266 Wi-Fi.h. So if you decide to use a different microcontroller, that library would change. If if you're trying to use an ESP32, you'd need to use a different Wi-Fi one. I'll cover that in a later video if there's any requests for that. And I'm also including the ESP NOW. Okay, so first bit, safety. Safety cutout. So just like with the big droids, I'm saying if you lose connection between the transmitter and receiver for more than 1 second, I'm going to shut the motors down. Again, it's not a big deal on a little droid, but it's good practice to be in. So I'm going to record what the last time we received a signal was, what the current time frame is, and if the difference between these two exceeds 1000 milliseconds, then we're going to shut down the controllers. It's not critical, but I think again it's really good practice to be in. So this is the bit now. This is the data structure. It's basically how our command is going to work. So we're calling it a structure message. I really should come up with a better name for that. A character array. So this is going to allow us to receive some text. If we want to use that text, we can. If we want to send some data between the two, we can, but for now, it's not a big deal. Int left motor, that's the clash that I'd got, and I didn't want to change everything. So I'm receiving the data for the left motor, data for right motor, and just for future proofing, data for the dome motor. And that's the end of this structure. I'm then creating a method is called DROID commands. So we could have many of these if we wanted to, but we're just going to have just one for this. So I'm now inside my setup function, just like before. I'm serial print lining. I'm saying it's starting up. Again, it's good for debugging purposes. If you've burnt the chip out, you'll never see that line of code. So it's good to make sure if your chip's still working. I'm saying setup Wi-Fi. Now this is a function I've created. It's further down in the code. And I'm still attaching the ls attach D3 and D4. So I'm still attaching left servo, right servo. So I had to change the names. Okay, so into our setup Wi-Fi function. So again, this is going to call this function. I'm disconnecting and erasing the config file. This just like initializes it ready for our use, just in case something old in there lying around. Don't worry too much about much of this. The only line we're really bothered about is this one. We need to know the MAC address. What is its Wi-Fi address, so they know how to talk to each other. So I'm going to set the mode up. I'm going to say output the MAC address, output the actual MAC address, and then I'm going to say this is our receive. So again, this is just a bit of debugging information, but this is critical. I'm now going to initialize. If there's a problem, it's going to say it. It's going to end the function. If it's okay, then it's going to continue with this now initialized. And now it also logs our on data receiver. This is another function further down the code. So if you rename anything, because you feel free to do so, make sure these match. Okay, so that's now our Wi-Fi up and running. We're going to our loop. Loop's nice and simple. I'm creating 3 variables, left motor, right motor, dome motor. Again, I know that's not in place. We shall add this either later this video or in the next one. We'll see, depends how long this one's running at. Oops. And this is our safety call out. This is our safety feature. If millis minus last millis is greater than max lag, so if that difference is greater than 1000, we're going to say it's lagging, and we're going to initialize these back to 0. So no matter what they were or are, they become 0. Otherwise, it would just retain the existing speed, and you don't want your droid running off. Again, with a full-size one, that can do some serious damage to droid and people in the way. But if that's fine, then we've no problem. We'll continue. This gets ignored, jumps onto this one, and we say go droid. So if our left motor has received a -1 signal, we're setting the 0. So we know it's going to be the reverse spin. If it's receiving 90, we know to stop it. If it's receiving 0, we know to stop it. And if it's receiving a 1, then we want full speed ahead. We could change this. We could change all of this function, this data structure up here. So instead of receiving integers, we could do a floating point number, and we could have variable speed. But it's a little droid, and most people using it, they're going to want it full speed or nothing. So that's it, and we'll do the same for the right motor, and that's our main code control loop. It's not particularly difficult, but I'll just finish off this bit of code so you can see what it's doing. So again, this is our data receiver. This function was provided by an ESP NOW tutorial, so I didn't write, so I've just pinched it. So again, this is where it records the timing by updating it. So if we receive some data, it resets the timer. Obviously, I could output the data, but I'm not going to at this point. and then I'm copying the memory from this incoming data into our DROID commands. Don't worry too much about this. This is very much C++ stuff about how much memory is it taking up, but the key bit is grabbing this incoming data and copying it to our DROID commands, which, as we know, is this connection up here, this DROID commands, this message, these three things, and that's it. That's how we're receiving this data. So if you want to send a lot more data for other cool things, different sound files, different lighting sequences, other cool stuff, you could just add it into this structure and then respond appropriately, and that's maybe something we'll look at in a later video. If you do want that sort of content, please do like this video, do comment below, so that I know that's what you're after. Okay, so that's our receiver. So the thing we need to do now is copy it across. So if you've not watched this last section, this is the bit you do need, but I'll have put a chapter point in. So I've got my board, I'm going to plug this in. So I'm plugging that in. It's obviously booting up the old code still, I think. And now we just need to copy it across. I'm going to make sure that it's not changed the port number, so it's still on the port. Sorry, something I should have mentioned earlier. I've also got mine on the ESP D1 Mini. I should have mentioned that in an earlier part of the video, because this is the ESP boards. If this is a problem for you, let me know and I'll do another video on how to set this up, but it is also one of my other videos. We're just going to copy that across. Once it's uploaded, we should start seeing some information. So if I go on to our serial monitor, okay, so once it's copied across, you can just untick the auto scroll, and I've just pressed clear output. I've reset my switch and I can scroll up and down, and this is the line that I was interested in. We can see it starting, MAC address, and there's the MAC address. I'm going to copy that because we need to copy it, and that's ready for our transmitter so it knows which one to connect it to. Okay, that is now our board ready for use. So I'll put it on the workbench. Okay, transmitter time. So into our transmitter code. So we've got the same sort of thing again. I've taken the old transmitter where I did the button test. I've just done save as version 2, and it's the same things. I need these same 3 libraries, so I've included those. I've still got the same defines for the pins, there's no change there. Receiver connection equals false. This is just a way of me tracking, has our little transmitter board, is it talking to it or not, just so I can see if they've connected. So the MAC address, this is the MAC address you just saw me copy from the other window. And then what I've had to do is I've had on our broadcast address, C4, you write C4 there. 5B goes there. So yours could be a very different MAC address to mine, but you need the 0x, and then you can put your code in. So you can see it's all the way across, and that's now making them talk to each other. So if you want to set up multiple devices, you're going to always need to come back to the Arduino IDE to output that MAC and then convert it into this in the hard code. There might be a clever way of doing it automatically, but I don't know of it. So again, I've got this exact same structure. These need to match. If they don't match, you're going to have some serious problems, like it won't work. So you can see these are the same data structures, the same names, everything. Okay, so if I scroll down, I've got this same thing you just saw on the other one. I'm creating this DROID commands. I've got a variable for incoming readings. So if I want to put sensors in the DROID and have it send data back, I can do that. That's not in this video, but I could do it. And these are the variables that would then store those incoming messages. Again, I'm not touching them right now, so I could delete these. So I'm in my setup again, same as before. My didn't realise I'd spelled that wrong. Didn't make any difference really. So I'm starting the ESP, starting Wi-Fi. I'm putting these delays in. It just gives me time to read it on screen to make it a bit easier for me to make sure things are working. But the delays don't need to be there. And then I've got the old pull-up pin things. Again, nothing changed there. So I set up Wi-Fi, pretty much the same thing. I'm connecting. I'm just setting the mode right. I'm seeing if there's any problems with it, and then a few of the functions. Again, I got this from an ESP tutorial a few years ago, so I've not changed anything that wasn't already on the web. But that's just now running the Wi-Fi. So inside my loop, I've got these variables. So again, just like before, LM, RM, and DM, ready for the dome motor. I'm just saying if it's low, if I press that switch, I've added this extra little bit to the end. So if we've pressed left forward, we're going to say left motor is 1. Forward. If it's not, it's left motor is -1, and if it's in right motor, etc. Same thing again. Now, because in the loop I'm initialising them to 0 at the beginning, I don't need to worry about what if I'm not pressing them. They're already 0. They will only change if I press a button. I then create the command. So I'm saying my string is this is my instruction, and I'm copying this element and RM to it. Obviously dome motor is still 0, and then I'm sending that message. So I'm sending the DROID commands that I've just made just here over to this device. So it's using the on data sent, so it's trying to send it, and if it doesn't send, if there's a problem, we're going to see that it's failed, because I'm going to get this failed message, and that is pretty much it. Again, on data receive, well, I'm not sending any data back other than did it receive it or not, but like I say, it could be cool for putting sensor information there or battery levels or things like that. But that's it, that's our receiver and transmitter. So again, let's copy this across. So I'm going to plug this in. This, of course, is now powering it. So if I just go into our serial monitor, there we go, it's booted it up, it's copied it across, and it's saying delivery failed because our receiver isn't plugged in. If I just now plug this in, we should see that message bar change. And turn it on. There we go, success. So this is still just plugged into the PC, so I'm using the PC's USB port, but now when I start pressing buttons, it should, there we go. But there we go, we've now got our little dome controls. Okay. And just to prove a point, I'm going to keep that one turning as I pull the cable out of the computer, and there we go, the motors have shut down, and of course that stopped reading now. So you've now got a working transmitter and receiver and the servos. You've got the full drive system. I don't know how long this has taken so far, but again, I imagine your printer might still be printing the devices, and you've got all the code, it's ready to go, ready to be installed. So the next section is going to be to obviously start building the DROID, or to transfer these over to a more reliable circuit board now you know that it works. Okay, now we've proved we've got our Wi-Fi working, we've got our transmitter and receiver working. I'm not totally about using the breadboard for the receiver part, so I'm going to convert this now over to some prototype board to make it a little bit more robust. So back over to the workbench. Now, it doesn't really matter what kind of soldering iron you've got as long as it heats up. I'm using a bench soldering iron, but I frequently use ones that cost like 12 quid off Amazon, so you don't actually need anything fancy. Okay. Now, one of the things that I tend to do, I'm not sure this is very good for the ESP, but I've got some little header pins that I put on. I don't like to solder the boards directly on, because then if this breaks, I can just pop it out and put a new one in. So I'm just putting the header pins onto the chip itself, just making sure they look straight, and then that gives them something to hold them in place while I solder it. Okay, so I'm just leaving myself a little bit of space, just so I can put some of these jumper pins, header pins on this side, and I'm leaving this space free for just in case I want to try and connect something else to it a little bit later. Okay, so I've got it fastened on. It's fairly tight by itself, so I don't need to really clamp it in place or anything. I've let my soldering iron get quite warm. I'm just going to clean that up a little bit. I tend to use some extra cheap sort of reading glasses just so I can see a bit better. Some people use those big magnifying glasses. I prefer the convenience of just cheap reading glasses. So I'm just checking the quality of each solder. It looks fine, should do. Okay, so the next things I want to do with those 3 pins. So this is obviously going to be the wires where the servos now connect. Okay, so we've now got the pins ready for the servos, but now we need to connect them up. Okay, I think that's okay, ready for the servos to be hooked up. So the next bit will be the power. Okay, so that's the power connector going from the pin 5 volts to there, so I've bridged the solder. Okay, so that's I would like to say quick, but it obviously wasn't. It's taken me quite some time just to solder up 2 connections for 2 servos, well, a connection for each servo, a power connector and a capacitor, just to sort of help filter out any potential problems. This is the reason I prefer PCBs, because I can just make them faster. Yes, you have to wait 2 weeks for them to be delivered, but you can solder it up so quickly. I could have done 10-20 boards in the time it's taken me to make that one, just because of fiddling and faffing and cutting wires down. So the big thing is, does this still work, or have I broken it? So first I'm going to plug the batteries in, and then keep smelling for any burning silicon. Okay, so far. Let's go and plug our remote back in. I suppose I could have used the power bank I've got sat next to me. Okay, so the left one's not kind of working, so what I've just done is I've brought up Arduino and I can see, okay, right motor's just fine, but when I press the left one, it's not quite having it. Okay, it was just one of the little wires that come out and I'd accidentally put it back in the wrong part of the board. So now we can see right motor. I think we can hear it in the background. Left motor. So it's now send the data, but we can hear it's not actually sending across. So I'll go and check the circuit. Did I make a mistake? Okay, it's really obvious. I don't know if you can see it on camera very well, but basically when I was bridging the connections, because obviously they're the negative, positive signal. If we look at the positive signals, I forgot to bridge the wires on a couple of them. Let's have a closer look. Can't see without my glasses on, without my extra glasses. So we'll use a pointy stick. So basically we can see I bridged these together. So this is the negative going across, connecting the negatives. This is the positive, I've got the jumper wire behind it, and I've connected those two, but I didn't connect this positive. And that bit of wire is in a bit of a dangerous spot as well. So I just need to bridge that with the solder. Okay, so I've just plugged those things back in, pick up the controller board. So that one was already working. There we go, so we're off. There we go. Okay, so that is now our control system with a slightly more robust strip board, prototype board. You've just seen how long that's sort of taken, so I'm not going to turn that into a more robust copy just yet, but obviously feel free, you've seen the process. If you want to convert that over, it is just a case of another bit of prototype board, plugging the parts in and strung the connections up just like they're on the breadboard, literally by matching it over. But it does take quite a bit of time. I'll explain why I'm not going to do it once we've got the DROID up and running. Okay, so the next bit is getting your files off the printer, and then hopefully you can start to assemble. Okay, as you can now see, I've got quite a lot of parts on the bench. I've got enough parts here to make 2 baby Astromechs. I've also got an R1 in the box, but I've only got enough servos to make 2 full ones for now, so I'll focus on one of them. I always think a good place to start is with the feet, because then you can start getting the motor drives working and not worry about anything else for now. So obviously I've got the legs, I've got the shoes, not the shoes, whatever they are. So I've got the servos on, and I think a good place to be is just to glue these on. Normally I use a bit of silicone glue because then you can sort of twist it off if you want to get it off from there. I'm just hoping this glue is good enough. A couple of dots should do. Okay. Oh, if you straighten it. Okay. So let's put that one to one side. Just do the other one. And we're not doing a full-size Astromech, that needs to be convention proof. So this should be sufficient. Okay. So obviously we've just glued the wheels to the circular hubs. If we have a closer look at obviously the one I made a few years ago, we can sort of see how they are fastening. We've got the little brackets. The little brackets, I'll hold the servo in place, and then that screws into place to hold it. So yeah, that's our right leg. That's going to be sort of coming in from that side. Okay. So basically we've got it's got a slight cut out. Should be able to sort of see it's coming to this top side. That's going to fasten in, and the servo is going to come fastening from underneath. So let's fasten that in. Okay, so I've just removed the wheels off the servos for the moment. So again, this is coming up from underneath. This is the side with the notch towards the top. I'm not using the screw that came with the servo. No reason. Just because I grabbed these first. Okay, oops. Maybe I should have done because that's not quite purchased it properly. Okay, that one's not going to come from the top, so I'm going to try from the bottom instead. This is the screw that came with the servo. Okay, that seems alright, so I'll just remove that one. I was hoping to come from the top because it would avoid messing about too close to the cable, but I don't think I'm going to get much of a chance to not. Okay, so there's our servo in its little bracket, so hopefully I've not made any silly mistakes. I usually do. So, okay, so that's going to fasten straight into there. So before I go any further, I need to feed that servo cable through. So there is a little slot sort of slide that in. It should come out this end. There we go. Just like in the full-size real ones. Yeah, last time. So I'm just using, I think it's just an M2 screw, nothing fancy, just out of my random toolbox of bits. Right. Okay, that's too small. Didn't grab a purchase. Let's have what else have I got in my toolbox. Got some M3s, but they're quite long. But I think I'm just going to try it anyway, see what happens. Well, the M3s seem quite big. Probably do some M2.5s, but I don't have any of those, so this will have to do. Okay, so that's in. But guess what I've forgotten to do? I've forgotten to put the wheel back on. Here's opens enough space to just squeeze that in. Oh, just. Okay. But of course, it does mean the wheel's not screwed onto the servo. I'll hope that'll not become a problem. If it does, I'll have to take it back apart and fix that later. And I think we can see that's why that little cutout's there now, for that cable to sort of slide through. A little bit trapped on something. Okay, so I'm just checking to make sure there's clearance between the cable and the wheel before I put the other screw in. So that cable's actually now in my way to put the other screw in. So I'm just going to pull that back out a bit if I can. Like that. Okay, so now we could put the battery covers on. I think that's the right way around. So that's the battery covers on, so I can fasten a screw through each side. Again, nothing fancy. Okay, so I've just put a single screw into the battery box to hold it in place. That's one leg kind of done. So now I can do the other leg. Okay, so there we go. That's now two legs made. Got the servos in, got the wires running through. Now obviously you should take the time to actually paint this before you start assembling too much, but yeah, no, time and all that. So the leg just goes on, and then a bolt goes through the shoulder onto the leg itself with the cable just there. The battery box itself is what should stop it from going too far. I can't remember if on the other one I actually put another thing through that hole, I can't remember. Okay, so I've got the bolt lined up, I hope. So this is an Allen key one. Okay, quick swap Allen keys. Okay, so there we go. One leg on. Now to the other side. And this is just an M3 bolt with a 20mm length. Again, it's just what's in the toolbox. A lot of these are leftover nuts and bolt kits from building the bigger droids. There we are, both legs on in the correct order now. So our next bit is to do the middle wheel. So, middle wheel. Okay, it's got a little caster in a bearing that fastens on and through. So let's have a little look at the parts we've got. Okay, so we've got 1 foot shell, ankle, and the other bracket. So we're just going to put that into there. So that's the screw's going to go through that once we've actually fastened this all together. So is there a right way around for that? No, should be fine, I think. Just making sure I'm not misunderstood. It's been a while since I did it last time. Okay, so again, I'm just going to use a random screw. You could probably get away with putting a nut and bolt through it. Okay, that was probably long enough. I'm just going to make sure it actually will go into that with some bite. A little bit. I think we should be able to glue that in as well, so I'm sure a bolt should probably go through that, but you know. It's quite a snug fit anyway, so I'm not too worried. And if it pops out, I can always really glue it in. So we'll also need a bearing. I can't remember what number it is, but it'll be in the instructions in the bill of materials. Oops, okay, that glue did not anywhere near hold. Maybe a longer screw to go through the whole thing, but we'll come back to that if necessary. Fairly sure it'll support its weight. I'm more concerned that that bearing just sort of fell out really easily. It's unusual. Okay, so we've also got the little ankle with that. Now, did I use a bearing last time? Yes, I did. We've got our wheel and our ankle and a bearing. I'm just going to put that bearing inside the wheel. Hope that kind of fits. There we go, it's quite a snug fit. Put that inside that part. Again, I'm just going to look for a random nut and bolt. We get a few turns through. It's on a bit of an angle. Hopefully it'll be okay. It's just starting to come through now, so I'll push this in the middle. Hopefully it'll get it all the way through. So it's already quite a snug, tight fit inside the plastic without a nut on the other side. You watch carefully to make sure it's not pushing that away, but it already is. Oops, just don't need to get it too tight. Let's wind it back a bit. Stay down there now. Okay. Okay. So I should really put a nut on the other side, but I've not got quite enough thread to get it on there. I could really do with taking it back out, but just for the sake of testing, let's push that in. Okay, it's not too bad. So I'm just going to use a little bit of silicone sealant, just a little bit. Oops, shouldn't have done that. I'm just going to put it on the outside of the bearing. I'm hoping this is not going to do anything too bad. Someone might be yelling at me now. Normally the prints have been that tight, it's not been needed. I'm just going to put a splodge in there. The only difference is this now takes a bit of drying time. But like I said, silicone's one of my favourite ones because it's a bit of elasticity to it, but it also means you can pull it apart. Okay, let's leave that to set for a little bit. Okay, so while the glue's drying on that little bit, let's get the dome. Inside the dome you've got the dome rings. This is going to allow it to sort of sit on top and rotate against the gear that we've not yet fitted. So if I just put that into place, and again I'm going to, before we go any further, so if we look at the other dome, I've got a nut and bolt coming through that sits into the body. Now in this one I forgot to put a bearing in because I did this absolutely ages ago and didn't read the instructions, but for this body I probably will put a bearing in. So before I go any further I will put a nut and bolt through. So again, going through my little kit box, because I haven't got something long enough. And again, these are just M3s. That's my longest one. I'd rather it too long because as we can see it'll sort of come down and through. That is quite quite on the tight side. Maybe it won't fit through. Okay, well, I'm going to force it. Other advantage of doing 3 walls, if you do 3 walls you've generally got enough to dig a bit of a thread into. So let's just... Okay, maybe this is a bit too long. So I might just leave that poking up with that amount of height. I might swap it out. We'll see how I feel later on. Okay, yep, I found a box of countersunk. So I'm just going to try and get these in now. These look a little bit long of what I've got left. Okay, so there we go. We've got our dome ready to go on, apart from not being painted obviously. So let's have a look. Have we got a kind of risk to this upside down now? Like I said, I've not had bearing in mind for 3 years, it's been fine, but let's see how it goes. Putting one in, because I've got one now. Will it just make it more difficult to put on? Oh, no. That's a lot better. Okay. It stayed in. So, let's find our circuit board and our battery box. I'm going to put the battery box in. Yeah, put the battery box in there for the moment. Now I can't remember which way around it was. Now, if you did want to zoom ahead, you could obviously mount your other servo by mounting the servo in there, putting the gear on it, and then fasten this in. And it goes from underneath, and then you would be able to just modify that code. Okay, so let's. I can't remember which pin on which, but we'll figure that out in a minute. So put the servo in. Especially label things. The servo in. Bring this wire through as well. Okay, so just slot that inside. So just turn this on. Just put it on top. Plug this into a battery bank. Okay, so I think that's probably enough to get you going for a full R2D2 in a weekend. You can drive it, you've done the electronics, we've got the code on there. I will do a follow-up video where I get the dome working, but also I will add an MP3 player so that it can play the recognisable R2 sounds. Now the reason why I'm not too bothered about trying to make this more robust, and I might do between now and the next video, depends on my mood, is because I wasn't happy with this when I did it 3 years ago, so I already made a PCB, a little PCB. It's the exact same circuit, but you can see what I've actually got is 6 switches, so I've got forwards and backwards, and I've got the 2 other switches where you can control either dome left and right, or you can do dome on one button for just one rotation, and the other button can trigger the MP3 sounds. So I have made these PCBs. Now if you're interested, I can do another video where I can show you how to make your own PCBs. The other option is if there's enough people interested, and if you are, please put a comment below. I'd be quite happy to sort of make up these little kits and sell them pre-coded, electronics ready to go. But that's, you know, if there's enough people wanting to do it to make it worthwhile, then I say comment below. I've also done the same for the drive board. You know, I've made this little board where it's got the MP3 player on it already, the Arduino, sorry, the ESP, but it's the exact same circuit. The only real difference on this, I've got a voltage regulator just to protect itself if you do put too big a battery through it. And on back on the transmitter, I also put a speaker and LED, and that gives you visual information as to whether it makes a little beep when it's booted up, and it also makes a little the light flashes to say whether it's connected or not, just like any sort of Bluetooth device would. So anyway, if you found any part of this video useful, please remember to like, subscribe to the channel, leave some positive comments below. If you've got suggestions for future content, please leave them. But other than that, I will get back to you with part 2 very soon, where it's got the MP3 player and what else was it? Oh yeah, the dome control. Okay, thank you for watching, and I'll see you in the next video.